Hello everyone! Welcome to this video lesson. Stay tuned and you will learn mathematics in just few minutes. Today, we are going to learn how to determine limits using table of values and graphs of functions. Limit is the unique real value that f of x will approach as x approaches c. It is usually denoted by capital letter L. So we usually say the limit of f of x as x approaches c is equal to L. Let's now solve for the limits using table of values. We have here the first example, the limit of x squared plus 1 as x approaches negative 1. First, our c is equal to negative 1. Let us assign the values of x. What are the numbers that approaches negative 1 from the left? We have negative 1.5, negative 1.2, negative 1.01, and negative 1.0001. In order to find the value of f of x, just substitute the value of x to x squared plus 1. So if we have negative 1.5, our f of x is equal to 3.25. If our x is negative 1.2, our f of x is 2.44. If we have negative 1.01, our f of x is equal to 2.0201.
And if our x is negative 1.0001, our f of x is equal to 2.000200001.
What are the numbers that approaches negative 1 from the right? We have negative 0.5, negative 0.8, negative 0.99, and negative 0.9999. Again, to find the value of f of x, just substitute the value of x to x squared plus 1. So the values of our f of x are 1.25, 1.64, 1.9801, and 1.999800001. What can you observe about the values of x? If you round these numbers to the nearest whole number, what do you think is the answer? Take note that the limit of f of x as x approaches c is equal to L if and only if the limit of f of x as x approaches c from the left is equal to the limit of f of x as x approaches c from the right. So the limit of x squared plus 1 as x approaches negative 1 is equal to 2.
Example number 2. Let's solve for the limit of f of x as x approaches 4 if f of x is equal to x plus 1 if x is lesser than 4, and if f of x is equal to the square of x minus 4 plus 3 if x is greater than or equal to 4.
Just like what we did in the first example, let's identify the values of x that approaches c from the left and from the right. From the left, we have 3.7, 3.85, 3.995, and 3.99999. Since our values are lesser than 4, so we are going to use x plus 1. So what are the values of our f of x? 3.7 plus 1 is 4.7. 3.85 plus 1 is equal to 4.85. 3.995 plus 1 is 4.995. And lastly, 3.99999 plus 1 is equal to 4.99999. From the right, the values of our x are 4.3, 4.1, 4.001, and 4.00001.
Since the values of x are greater than 4, we will use the square of x minus 4 plus 3.
Just substitute the values of x to square of x minus 4 plus 3, and you will get the following answers. Based on the given tables, the limit of x as x approaches c from the left is 5, while the limit of x as x approaches c from the right is 3. Take note they are not equal. From this example, we can say that the limit does not exist if the limit of f of x as x approaches c from the left is not equal to the limit of f of x as x approaches c from the right. So the limit of the given piecewise function as x approaches c does not exist. Let us now solve for the limit using graphs. We have here the graph of f of x. Let's determine the following limits. The limit of f of x as x approaches negative 4. Look at the graph. What is the value of y if x is equal to negative 4? The answer is negative 5. So the limit of x as x approaches negative 4 is negative 5. The limit of f of x as x approaches negative 1. If x is equal to negative 1, what is the value of y? The answer is 4. So the limit of x as x approaches negative 1 is 4. Can you now determine the limit of f of x as x approaches 1? If you answered 4, you are correct. What is the limit of f of x as x approaches 3? It is negative 4. Lastly, what is the limit of f of x as x approaches 5? The limit of f of x as x approaches 5 is negative 2.